Okay, so we now move into the first of several sessions looking at daylight simulation and visualization. So we've got this session now, we've then got another 50-minute session following this, which is more of a workshop looking at visualization, and then we continue next week. Now the reason we spend so much time, two reasons really. One, it's an area where the software is very capable. So in terms of daylight simulation and visualization, the software is actually quite advanced. Also, second reason is I think it's an area where architectural designers, architectural consultants, engineers can have a really big impact on the performance of a building. So getting the daylight right, getting the sunlight right is a real key area, and the software allows us to design that to a high level of sophistication. Okay, so we'll go into Revit, and I'm using today a sample file which is available for you on mobile. It's actually a file which was created by one of my students a few years ago, but I use it because it's a good model. It's got a good level of furniture in it. It's got a lot of equipment in the model. Okay. Now the model, I have tested it and it does work, but if for whatever reason it won't work because it's quite a large file, then what I'll do is, if that happens, I'll have to change to a slightly smaller model. Okay. Now, what you will see, if we start just by looking at this interior view, is look at the kind of quality of the furniture and equipment that the studio has put in this model. It's what we tend to call dressing the scene in terms of visualization. So you start with, when you're building a model of a building, it's an empty shell, but we only really can start to understand those spaces once we start to put all of the kind of equipment and furniture that we're used to in a building. Now, in your scenario, in your assignment, the building that I've provided you hasn't really got any furniture in it. And that's one of your tasks, is to make it feel like a real building by putting in some furniture. Now, you've got this Revit file, you can grab this furniture and put it in. There are a few links on Mole to some free sites to download Revit furniture. It's really, it's very easy just to place furniture and equipment. Okay, so we've got an interior view here, but what I want to do first of all is just show you how to create an interior view from scratch. So the first thing is, let's go to a floor plan. Okay, let's just try this one, and let's zoom in a bit, and let's place a camera in this view. In today's session, we're looking exclusively at three-dimensional simulation. Next week, we'll look at some two-dimensional skills. So, view, and we need to go to 3D view and camera, and you can probably just about see there's a little camera kind of stuck to my cursor. Okay, little camera there. So what we now do is we go into our room. Before we do that, if you notice here, it's asking us what height do you want your camera. And by default, it will position it about 1750 above your floor level, which is a sort of fairly normal eye height. Okay, so I'm going to leave that alone. And it's from level 1. So I want my camera in level 1, so camera will be about here, which is fine. So click to drop your camera, and then it's asking you to point the camera, and how far do you want that camera to see? Now we can change this all later, but I'm going to point it. Let's try looking down there. So I've clicked again, and it opens up our view. WT Windows tile, just get rid of that one. WT ZA. So there's our camera view that we've created, and there's, in the right hand window, you can just still see the camera. Now, if I deselect that view, this can be a little bit confusing. When that camera view is deselected, you can't see where your camera is. But as soon as you select that camera view, your camera reappears. And if we then go into this window, we are free to move that camera around. Okay? Just zoom out a bit. The other thing to watch for is the depth, which is this. If I drag that depth a little bit there, then what you might, in fact I'll do it more. You can limit how far you want to see. So I've pulled that depth back, and that door has disappeared in the view. So you can do that if you want. Just make that a bit deeper. Then you've also got the direction of your camera, which you can change by just dragging it around like that. And then how wide do you want that camera to be? Now, the way Revit, the kind of easiest way that Revit uses the camera is, rather than typing in a kind of camera lens like 35mm, 50mm, you can just simply grab the edges of your view like that and just make it a bit bigger. So it's quite an easy way of just manipulating your camera angle, your camera view. Okay, so we've created a view in that space. Let's just move that a little bit. And I'm kind of interested to see around the corner there. So I'm just going to try moving that camera over a little bit until I can just get that little peak around there. Yeah, I just wanted to get that view through to that stair in the distance. I think that would be quite interesting. Okay. ZA, zoom all. So we've created a camera view there in our window. Now, before we do any kind of complex daylight simulation, what we can simply do is switch the shadows on down here. So we'll put the shadows on. So we're getting a shadow pattern now in that room, and as a very kind of first stage sunlight simulation, you might simply change those, go into your sun settings here, and maybe change your sun position and test that sun in a few different positions. So I'm going to move that to 9 o'clock in the morning. Let's try that in 22nd of July. Let's try 8 o'clock in the morning. Okay, so we, got a different shadow there. The reason in this model the shadows all kind of fragmented is because outside of the building there's a very complex shading screen. I can probably show you. Show you that image, I think. So if I show you a view, this is a view of the exterior of this building. So the light, those shadow patterns that we're getting are coming through this complex shading screen, which is why it's so kind of detailed. Okay, back into Revit. So we've got our view, and what we're going to do, first of all, before we get a more kind of accurate daylight simulation, is let's just get a render of that view. So before we get into the kind of numbers, let's just get a feel for what that space might look like. Okay, what it might feel like and look like. And we're going to introduce you now to the render in the cloud facility in Revit. And the cloud rendering, it's also, Autodesk call it, I think they call it 360, they call it Autodesk 360 as well. But basically what it means is, rather than rendering on your computer, you send the information off and Autodesk render it for you. And it's really powerful. Now you can render in your computer, and if you click the top button, render, then Revit will render this image. But it will take an hour maybe, depends on your settings. It could take 2 hours, it could take a long time to do that. The cloud render, I think, is a much better way of working. So let's get straight into that. You need to be signed in, okay? So Autodesk A360, that's what they call it. So you need to be signed into your account, first of all. Click on Render in the Cloud. This screen is just a little set of instructions. I'll just skip over that. Okay, so you're brought to a dialog box which is going to allow us to package up this model and send it off to Autodesk. It's a little bit small there, but I think we'll be okay. Okay, few questions. Which view do you want to render? Now, I didn't give this view a name, so it's by default it's called it 3D View 1. In fact, I'm going to come back out of that and give this view a meaningful name. So I'm going to rename that, and let's call it View to Stare in Cafe. Okay. If you don't give things meaningful names, when you're trying to find your renders, it's not very helpful. Okay. Much better to give them a proper name. Let's go back. Render in the cloud. Skip this first one. Give it a moment. Okay, so choose your 3D view that you want to render. And can we find it there? View to Stare in Cafe was the one that I want to render. Now, you can actually send as many off at the same time as you like. I'm not going to do it now for speed, but you could, for example, create 6 views, set your sun, send them all off to render. You can do as many as you like. I'm just going to fix to that one. Okay. output type. For the purposes of a render, we leave it on still image. Pretty small up there, isn't it? But that says still image anyway. Image size. Oh, sorry, render quality. Personally, I just normally put that on final quality. There is a standard quality which is not quite as good. I normally just put it onto final quality. Image size, you can go up to 16 million pixels. So pretty big render size if you want. I'm just going to leave that on 2.25 megapixels for now. Okay. Exposure, advanced or native, I just leave that on advanced. You can play around with that, but I'm just going to leave that alone. File format, I'm just going to leave that on PNG file format. Now, what you might notice down here is it's talking about cloud credits. Can you see that? Yeah, you can see that. Okay. So, cloud credits, if we were not getting this service for free, cloud credits are credits where you'd have to pay, basically. So if you're using Revit commercially, you'd have to pay. And the way it works, depending on the size of your render, you get charged credits. Now, luckily for us, we've got unlimited credits because Autodesk give us unlimited free credits. Fantastic. So we don't really need to worry about that. They do limit us on 16 credits per request. Now, you can still go up to 16 megapixels, I think. Yeah. So you can still go to the full size 16 megapixel render, and you're within our 16 credits maximum. I'll show you in the session later on, you're slightly limited when you want to do an interactive panorama. And all Autodesk are doing really is they're kind of saying, well, look, we're giving you this away for free, but we have to put a limit on how much you can do. All right. Estimated wait time. It's saying less than 10 minutes. Now, it's a bit of an estimate that. The thing to bear in mind is this will go off to Autodesk, to their servers. Now, depending on how many people are sending renders through, it can take longer or shorter periods of time. I know some students have said occasionally they had to wait a few hours. I normally find it's pretty quick, okay? But the thing to bear in mind, even if you are waiting, you might as well send off 10 or 20 renders. You're waiting, but your computer is not being held up with the rendering. Okay, so we're ready. You can check email me when complete, but I'm not going to bother with that. So we'll send it off to start rendering. This file has a few missing materials in it. So we'll get a little warning message in a moment, which is just going to say that we've got a few JPEGs missing. And I keep meaning to fix them, but haven't got around to it. Basically, all it means is all of the materials that come with Revit, they all work. They've all got images associated with them. This student created a few materials himself with some JPEGs for textures, and I haven't got the JPEGs. So, as you can see, these are missing. It doesn't stop you performing the rendering. It just means that if those materials are in this image, they're not going to have that JPEG texture. That's okay. Okay, so it's sent. It's gone off to Revit, to Autodesk, and I'm free now to use my computer again. So we'll send another one off, and then we'll go and have a look at how they're getting on. Okay, so let's go back into render in the cloud. Skip the first task. And what we want to do now is not a rendering as such, but we want a more accurate daylight simulation. So we still want the same view, but this time under Still Image, Interactive Panorama, we need to select Illuminance. And we'll start off with a direct sunshine illuminance study. So we're going to simulate this room with a direct sun. Okay. Again, image size, I'll put that up to large. And then the next box, we've got location, time, sky model, and legend. You can check use the date from the view here, and that should take the sun settings that you've got already set up in your view. Or if you uncheck that, you can overwrite that and change the date and the time here. I tend to use the date from view. Just check that. I have had a few issues occasionally when it doesn't take the date from the view and it's defaulting to the current date and time. Caught me out a few times when I was doing some renderings late at night and they all came back black because it was taking the middle of the night. Okay, but just watch for that. So I'm just going to set the date from the view and hopefully that will work. Next one, sky model. And you have a drop down here. What kind of a sky do you want to use? Now, I'm not going to get into too much detail here, but we've got a choice. A Perez all-weather sky, an overcast sky, an intermediate sky, a clear sky, a uniform sky, or a daylight factor sky. Now, for an illuminance purpose, it would be quite common to go with an intermediate or a clear sky. And you need to decide what are you simulating. So I want to simulate a sunny day with bright sunshine. So I'm going to go for a CIE clear sky in this instance. I'm not going to mess with the daylight parameters of the sky. I'm just going to leave it as the default. Legend. Okay, we don't use foot candles in the UK, we use lux. So change that to lux. And you need to set the scale. Basically, what Revit is going to do, it will color code this rendering between the range that you set here. Now, 200 lux is quite low. So I'm going to set that at 2000 lux. So we look from anything from 0 to 2000 lux. Anything above 2000 lux will all come in the same color. Now, the way to work here quite often is try the render, see the results, then come back, change the settings, resimulate. It's very quick. Okay, so that one's ready to go. So we'll send that one as well. Give that a moment. It'll bring up the error message again for the missing JPEGs. I mean, this is taking a while because this is quite a big file. You know, we've got quite a lot of detailed surfaces, detailed complex furniture in here, which is why it's just taking a little while. It doesn't normally take this long with a normal file. Okay. So we get this menu here. Do you want to continue in the background? Yes. Okay. So we're back. We can start working again. Let's go and send another render off. Render in the cloud. Continue. Okay. Let's select Illuminance again. But we're going to do something different this time. We'll set it to 2.25 megapixels again. We'll take the date from the view, but this time, under the sky model, we're going to choose a daylight factor sky. Okay, so very different kind of simulation now. A daylight factor sky. So we're not interested in direct sunshine anymore. We're looking at an overcast, cloudy sky with a kind of uniform level of light from all directions. And that's the daylight factor sky, which is very useful. Go into the legend. Now, you notice that your units are now grayed out here. So it says foot candles, but it's grayed out. A daylight factor simulation is a percentage. So it hasn't got units as such, which is why you can't change them. But you can set the percentage range. So it, by default, 0 to 100%. But inside a building, I typically start in the range of 0 to 10%. And you'll see when we get the results what that means. Okay? And let's send that one off again as well. I mean, the thing to bear in mind is I'm talking and explaining while we're doing this. But if you're simply sending off these renders, probably within 30 minutes you could probably send off 10 or 15 renders. So it's a very quick process. The other thing, of course, if you were rendering in your computer, you'd have to wait for the first render to finish before you could send the second. So you're talking about days. I mean, traditionally people have to, well, you either have to have more than one computer, or you have to send the render and then, go to bed. And by the morning it might be finished. But I think this is a better way of working. Okay, we've sent off 3 renders. Let's go and have a look at them. Your renders are accessed via a web page. Now, if you know the web page, you can just go to that web page. You can access it on a tablet, on anything. There's a shortcut to that web page which is called the render gallery. So if we click on that, it will take you to your render gallery. Let's give that a moment. Okay. Now I'm actually going to open this in Chrome instead. So I've just copied the web address there, paste it in to Google Chrome. Okay, so it brings us into the Autodesk A360 web page, basically. And what this does is it stores all of your render history, and it makes it accessible to you as a web platform. Now, in the next session, I'm going to show you some of the more complex tools. But for now, the important thing is just to look here. You see we've got the spinning wheel telling us that we've got some renderings that are busy rendering. If we change that to, let's change that to all renderings. And what we can see now is we've got some renderings which I sent last night. And these are the renderings that we sent this morning. So for example, this one, it says rendered 3 minutes ago. This one rendered 2 minutes ago, and they are clearly not ready yet. This one, however, rendered 10 minutes ago. The bar along the bottom suggests the remaining time is 4 minutes. Let's click on that. So it's not finished rendering, but we can still view the progress as it's rendering. Okay. So that one's busy rendering, but let's go into one that I sent last night. Okay, so there's the image that I rendered last night that's finished. If we if you hover over the thumbnail, click on the drop down, you've got a number of different options, which we're going to talk about those a little bit more in the next session, but probably the most important one, download image. So that image will now download in full resolution. Just give that a moment. It's coming. It's not. No, I don't know why it's taking so long. It might just be the Wi-Fi in here. This was another image that I sent last night. Okay. So there's the rendering that I sent last night. Okay, I think that was at 2.25 megapixels, and I think the thing to understand is it's a very good daylight rendering. Now, in this example, we've not got any direct sunshine, but the Revit Cloud Render is a very good simulation of bouncing daylight around. So you get quite a realistic impression of that space. So it's not a kind of full photorealistic rendering. It's not 3D Studio Max. But what it is a very good daylight rendering where the quality of light, the accuracy of the reflections of the light, the quality of the sun is quite realistic for your site. So that view that you get of that room is probably quite a realistic view of how that room would look at certain times of the year. The criticism of many kind of commercial renderings is to make the building look good, they always put it under fantastic sunshine, really bright, strong sun, which is not terribly realistic. And what I quite like about the Revit visualizations is you get a more kind of real daylight quality of that space. Okay. I mean, it also depends on how well you model. So, for example, these chairs, I think they have a very good quality to them. The kind of colour of them looks about right. If we look over here, we've got some glass with some bikes behind it. We've got some nice reflectance on the glass. All those things that the eye gets quite convinced by, things like reflection. Okay, let's just go back into here. Okay, you can see we're getting progress now with our other renderings. This one is now finished. So that's the one that we sent first. Okay. That's looking okay. that is bigger than this is just a preview image. We can obviously download the full version. And our simulations of daylight are not quite finished yet. What I'll do, yeah, that might not be finished in time. What I'll do, I'll just go to an example one instead. You get, on your thumbnails, depending on the type of image, you get this little, you see this little sort of icon with the light bouncing, the arrows. That indicates that it's an illuminance render compared to a normal render. And there's also an interactive panorama, which I'll show you in the next session, which allows you to pan around the image. But for now, let's go into, how's that one doing? That one's finished. Okay. Right, I'm going to download that one. Okay, well, while that's downloading, the delay here, I think is just I'm not sure, it's just the Wi-Fi or whatever. So I'm downloading that. So that was our Illuminaance study that we sent, the first Illuminaance study. So you remember I talked about setting that scale, and I set it from 0 to 2000 lux. So what the simulation does, any surface in the model will be color-coded depending on its illuminance level. So that wall is yellow, which tells you it's 2000 lux or above. That tabletop in the dark red puts it in about 1000 lux. The tables further back here in the green put that in the sort of 600 lux scale. Now, as a guide, for a normal kind of working environment, you're aiming at about 300 lux on a work surface, or for more precision work, like drawing, you're aiming for about 500 lux. Anything below that is probably too low for normal kind of work. Equally, anything above 2000 lux might be too bright. Okay? So that's just a kind of guide. So we've got our visualization view there, and then of exactly the same view, we've got an illuminance study with a direct sun, with a clear sky, and obviously you could then re-simulate that moving the sun around. And then I think it's finished. We have a daylight factor simulation of the same. Yeah, that's finished now. And we set that daylight factor scale from 0 to 10%, which looks about right for me. So if you remember from, I think we talked before, daylight factors, you're looking for kind of 2 to 3%. For a reasonable quality of daylight. 5% will feel quite well daylit. Anything up to 10% is probably really good daylighting. So if we look in our room here, this table which is the table right behind the window, is in the sort of 8 to 10%. This table at the back is in the sort of 3%. And as we move back into the room, it's getting quite dark, and we're down in the sort of 1% daylight factor. So you're getting that, that kind of quantitative understanding of the space. Next week, we're going to look at how you can produce the same metrics in a plan view. Okay? Today, we're just looking at the 3D views. So we're going to have a break now, but that's the kind of the first stage methodology, that from the same view, in order to understand the daylight in that space, you need a daylight visualization, probably at different times of the year. So that's one. You need an illuminance study, which considers a direct sunshine. And again, you need that at multiple times in the year with different suns. And a daylight factor simulation, which is simulating an overcast sky, and you only need to do it once, because in an overcast sky, for a daylight factor, it's the same sky in the morning as the afternoon. It's the same sky in January as it is in July, which is why the daylight factor simulation is the easiest and the quickest. Okay, so 3 different types of simulation there that you need to start to understand the quality of daylight in a room.